We're here in Cumnock, Scotland. This is one of the workshops of Emergency One UK. They've been our technology partner through this. I'll take you on a little bit of a tour underneath the truck. We're going to start out at the front of the truck. What you got here is a cooling package that's completely run on electric. We've got 6 24-volt cooling fans.
And those fans only run as needed.
The reason for that is we want to be as efficient as we can with all of our electrical power.
And they are variable speed, so even when they are running, they're quieter than what you'd experience with a normal belt-driven fan on a normal diesel engine. But it does two duties. It cools the range extender as needed, but also cools the electronics, the inverters, as needed as well.
We move back here, you're going to see the underside of the range extender. So this is our Cummins B series engine. This is basically just there for emergencies.
The vast majority of the time, it's not going to be running. With the large 316 kilowatt hour battery packs, they're only going to be running on battery. You'll never need that engine.
Here is one of the battery packs. So these battery packs are nominally 800 volts. There's 6 altogether, and each one of these battery modules is a whole series of pouch-type cells.
The battery system features a battery management system. It has almost 900 sensors on the battery cells, measuring temperatures, measuring voltages, measuring currents. The battery management system protects those batteries and ensures a long life.
They're also completely sealed. We could run these meter underneath water, so any kind of fording problems, not an issue at all.
The battery set on this vehicle is 315 kilowatts. DC fast charging, you can charge it to 50% from 0 in approximately 1.5 hours, and it can be charged to full in 2.5 hours.
The next thing you're going to see is a pan covering the inverter set. So the very bottom piece down here is the power distribution unit.
The power comes out of the batteries through our main power distribution unit and into a series of inverters.
The inverters are what's going to take the power from the batteries, DC power, turn it into AC, and then feed it to the motors.
We end up with 4 different AC feeds to the main drive motor. This allows us to switch stages on and off and fully control the motor to offer the best possible driving for that exact situation.
We're going to walk around now the top side of the truck. We've dropped it back down, and I want to show you some of those same components and a few extra ones with a better view from the top. If you pan around here, you're going to see these are all Class 8 heavy-duty North American fire truck parts. So this electric vehicle is everything that today's Class A fire truck is, and then some. These are 6-phase AC motors. You can see all of the cabling coming into the motor here and here. 1, 2, 3, 4, 5, 6 phases on this. On the back motor, again, it's 6-phase. 1, 2, 3, 4, 5, 6. Together, it actually makes a 12-phase tandem motor.
The motor itself is actually made up of 2 motors, each of which is 6 phases. In total, the full drive motor features 12 phases of AC power. This offers excellent tunability, control, and flexibility on how many phases we are using at any given time, how many stages of the motor we use at any time, to make sure we get the driver what they're requesting, when they're requesting it, and with the best possible efficiency at the same time.
Very powerful. In fact, over 500 horsepower out of these 2 motors together.
Any information that is on the vehicle canvas is recorded within the telematics unit. It is stored on the vehicle. It is sent remotely via cell connection to a remote server, and it is stored there. And then that information is available for the user to interrogate and to check how their vehicle is performing, but also for the Rev Group service engineers to see how the vehicle is and to remotely diagnose any problems that may occur on the vehicle.
So we're at the Vector all-electric fire truck. We're going to show you how to pump water. We're at the scene, got the parking brake engaged, and on the shift pad, we'll come up here, engage the pump.
The electric motor is behaving in the same way that a diesel engine would on a standard fire truck, except that you've got much greater, much finer control of that motor. It is easier to have stable pumping. It is easier to react to the pumping, to speed up, to slow down the pump. It's better operating experience for the pump operator.
Come back to the pump panel. First thing we're going to do is turn on the pump. In this case, we've got a couple of discharges. I'm going to open those two. So we're flowing water. I'm going to hit my 110 psi preset. Want a little more pressure? 150 psi preset. We're pumping water. Most of the noise right now is all coming from the hand lines. You can see the pump itself is very quiet. Are you done? And turn the pump off. That's all there is to it.